Assalamu alaikum. Hello, my name is Shadib Hassan and I'm a chemical process engineer. Today we are going to conduct an interview session with Mr. Benard Osiron, who is the chairman, founder, and managing director of a newly registered company, Apple Vision, in Kampala, Uganda. We invite him and ask him about his motivation of opening a new company in Uganda, the challenges he has faced, and uh, also we will ask him few technical questions to create an interest for the audience. So let's welcome him. Hello, Bernard. How are you today?
I'm okay. Thank you very much.
So
I hope you're fine.
yeah, I'm good too. Let's start with your introduction and your company introduction. Apple Vision.
Thank you very much, Engineer Hassan. My name is Benard Osiron. I come from Uganda, and I'm speaking right over here in Kampala. The time is just 12 minutes to 2 p.m. I'm the founder and the managing director of Apple Vision Limited, and I'm a chemical engineer by profession. Apple Vision Limited is a multidisciplinary consulting and engineering company registered in Uganda. We provide consulting services, and our purpose is to serve and promote sustainable development in all projects that we do and in all communities where we operate. So we are a team of professional engineers, planners, accountants, scientists, lawyers, and our aim is to come together and integrate our knowledge and skills from end to end so that we can come up with innovative solutions to world's most challenging problems. Thank you.
What kind of consultancy services you are providing right now?
Yeah, we have, as I've said, we are multidisciplinary. We provide consulting services across the business and engineering sectors. We provide business and management consulting services. We provide survey services, building and construction services, energy and climate protection services, manufacturing, oil and gas services, water and environment, and many other sectors.
That is great. So what challenges you have faced while you were opening your company in Uganda?
Of course, the first challenge is making the idea clear. You can meet many people, and when you discuss with them about your idea, they seem not to be understanding in the first instances. But it depends on the people who are listening. But in most cases, people who have been in the field and who understand the challenges of the world sometimes try to understand. So the challenge is making the public get to know exactly what we intend to do. But that has been now cleared because it is now clear.
Great. So let's start with some technical questions. Are you okay?
Yes, I am fine.
So suppose we have a pipeline and water is flowing through it, and we want to measure the velocity in a pipeline. Then what do you think? How can we calculate it?
Pipeline is one of the most common way of transporting fluids in the processing industry. And knowing the volume or the velocity is one of the key parameters that we need to know if we are to be able to control the flow rates or the process parameters. Now, in a piping system, there is an equation called the continuity equation. This is an equation which assumes the law of conservation of matter holds. Like if you have a fluid flowing in a pipe, it is assumed that at one point, the volumetric flow rate is the same. When you look at a cross-section of that pipe and you consider 2 points, point A and point B, the volumetric flow rate at point A should be equal to the volumetric flow rate at point B. Even when you have that pipe and it is one long pipe, but it has branches, the volumetric flow rate towards the junction should be equal to the sum of the volumetric flow rates of the individual pipes that emerge from the junction. So when we are to determine the velocity, we consider that equation holds. So we get the volumetric flow rate, for instance, at point A, and we equate it to the cross-section area times the average velocity. Actually, we call it average velocity because in the piping system, when you look at the flow of fluids at the pipe surface, because of the shear force, the velocity of the layers is 0. Then as you move towards the center, the velocity increases. So when you draw the graph of velocity against that distance, you will have that velocity profile. So in a piping system, in fact, we usually compute average velocity. So the average velocity becomes the volumetric flow rate over the cross-sectional area of that pipe.
Very well explained, Benard. And what do you think when there is an open channel and you want to calculate a flow rate? And how will you calculate it?
Come again?
There is an open channel and water is flowing in an open channel, for example, and you want to calculate the flow rate. Then how will you proceed with this?
Yes, for it to be able to calculate the flow rate of an open channel when water is flowing, you, like a channel, if it's a pipe, right?
No, it's open. It's an open sea, like you can say it's sea or anything open. A water channel.
Like in a swamp area, something like that.
Yeah.
We have flow meters.
And
We have flow meters. Yes, we have flow meters.
And what kind of flow meters? Is it ultrasonic or any other technology?
With an open channel, you can't use ultrasonic. Ultrasonic flow meters are for piping systems.
So what do you think about V-notch weirs, which usually calculate the flow rates in an open channel? The square shape and V-notch weirs, which is installed in an open channel to measure the flow rates. Do you have any idea of it?
No.
Okay, great. So what do you think about the ultrasonic flow meters?
Ultrasonic flow meters are used for measuring the velocity of the fluid flowing inside the pipe.
And what is the procedure?
They use transducers.
Great.
And they are, in most cases, they are connected on the outer surface of the pipe. And these transducers are in pairs. and they have the ability to receive and transmit ultrasonic sound waves. So usually when there is no flow in the pipe, the transit time, that's the time between sending and receiving of the sound waves, is usually the same. Now, what happens is that one transducer is connected on the upper or the upstream of the pipe and the other on the downstream. So when water starts flowing or any fluid starts flowing, the rate at which the sound waves move differs, in that towards the downstream, the speed increases. And then against the flow, the speed of the sound waves reduces. So as these transducers send and receive these ultrasonic sounds, the difference in the time between the upstream and the downstream usually gives the time which helps us to calculate the velocity. And once we know the velocity, you can compute the volumetric flow rate. So that's how ultrasonic flow meters work.
Are there oil refineries in Uganda?
Yes.
Are there oil refineries in Uganda?
Uganda, currently we don't have oil refineries in Uganda. The industry is still new and they are just trying to build oil refineries. We have not yet started commercial production.
So you are importing oil from outside?
Yes.
100% import?
Yes.
100% importing the fuel?
100%. We haven't yet started our local production.
Great. So what do you know about the chemical reactors in a process industry?
As chemical reactors, these are vessels that transform raw materials into finished products. And they are in various types, depending on the purpose. We have the batch type reactors. These reactors is a tank where the reactants are put and they are given time to react. And then after some time, the products are withdrawn. So in such reactors, there is agitation which is provided to ensure these reactants mix well. So the conversion in batch reactors actually depends on the residence time. The longer the time the reactants stay together, the higher the conversion. Then the other reactor is the continuous stirred tank reactor. This is also a tank, but in this case, the reactants are put at the same time, the products are withdrawn. It's something which is continuous. As products are put into the reactor, the products are withdrawn simultaneously. So in this case, because of the uniform mixing which takes place within the reactor, the concentration inside the reactor is actually the same as the concentration at the exit stream. So the conversion for this particular type of reactor is based on the volume of the reactor. Then the third reactor is the plug flow reactor. The plug flow reactor is a hollow tube, a hollow pipe, and in this case, the reactants flow in the same direction continuously. It's assumed that with this type of reactor, there is no mixing of layers. For instance, if you look at a particular layer within the reactor, it should not mix with the one coming before or after it. So the concentration varies across the length of the tube. And when you look at the entries, the concentration of the reactants is very high. And as you move downwards towards the exit, the concentration of the products is higher, because as the reactants flow down the stream, there is conversion taking place. So actually the reactor, this particular type of reactor, the plug flow reactor, it solves the limitations of the stirred tank, continuous stirred tank reactor, because when it comes to the continuous stirred tank reactor, in most cases, the conversion is very low, because most of the reactants may have long residence time to be converted. So because of this continuous addition and withdrawal of the product, in most cases, you find that the conversion is low. So mostly there are three types of reactors in the chemical industry, but there are others depending on the purpose. Like you may have a reactor and you put there catalysts. It may be a plug flow reactor packed with catalysts. So the three major ones are those I've talked about.
What about the downflow reactor and radial flow reactors? Like when we talk about a reformer unit, there is usually three reactors with different sizes, and they are all radial flow reactors, or it could be downflow reactors. But what should be the difference between these two?
Well, in my first employer, I worked in a water treatment plant. The way we used to treat this water, we could first do a physical separation to remove physical pollutants, and then we could remove the organic pollutants. Now, the way we removed these organic pollutants from the water, we were using activated carbon, which was packed in a vessel. So, yes, so water could flow from up downwards through the packed bed. So in that case, the organic pollutants could adhere on the surfaces of the activated carbon. So when it comes to downward flow or downflow reactors, we usually get the fluid flowing from up downwards, and in most cases it's by gravity. Then the separation or the reaction occurs within the vessel as the fluid flows downward. Then when it comes to the radio, like I talked about the batch type reactor and then the continuous stirred tank reactor, where the stirrer is provided at the center. What usually happens is that this stirrer, it's mechanically driven, and as it is moving in a circular motion, it exerts pressure against the fluid around it in a circular way. So this fluid also starts rotating, because the motion or the force is exerted at the center, and the fluid starts moving outwards in a circular way. Then that's how we get the name radio flow, because it exerts pressure in a circular, and the fluid moves radially in a radial motion, circular motion. So that's what happens in batch reactors and the continuous stirred reactors.
Great. So discuss about the filter coalescer, its role, function, and why we are using coalescers in process industries.
Come again?
I'm talking about the filter coalescers. That you see that there are various kinds of process industries in which this equipment is installed. But what is the purpose of installing it?
Installing, come again, I haven't got you clear.
I'm talking about filter coalescer. Like filter coalescer is used in many industries around the world. But what is the purpose of installing it?
What's that word? I'm not getting that word.
Filter coolescer. Talking about filter coolescer.
Filter?
Coolessers.
What's
Coolessers,
the speed?
any kind of equipment which separates water from hydrocarbon is a coolescer. So I'm talking about filter coolessers, which is
Filter.
yeah, filter. Anything that separates water or provides separation is a filter. Filter.
Yes, filter. Then the other word is?
Coalescer.
What's the speed?
COALES.
Okay. Coalesce. Coalesce. Yeah, I get you. Coalesce filter. Well, this one is found in mechanical separators.
Yes.
There are actually baffles that are installed within the separators. They are used for separating liquid droplets from gas. For instance, if you are in a natural gas plant, what usually happens is that to ensure the quality and the dry level of the gas, we need to remove the water droplets. So what usually happens, these baffles are installed within the separator system. And as the gas flows upwards, it gets impacted on these baffles. And because of that impact, it loses some energy, which causes the liquid droplets to adhere on the surfaces of these filters. Now, first of all, even the filters, they have a higher affinity for the water droplets than the gas itself. So as the process continues, there is a buildup of the droplets into bigger particles that eventually fall down. These water droplets fall down and they are channeled off from the system. So the principle here is basically causing the water droplets building up into larger water droplets and then falling back and leaving the gas flow without the water droplets.
Tell us about the cooling towers types.
Yes, cooling towers in processing industries, water is the major coolant. And from an economic perspective, it's better to recycle this water if necessary. But because the exit stream usually brings this water at a very high temperature, it's important to first cool this water before it can be recycled. So that is achieved in a cooling tower. A cooling tower is usually made up of concrete. There are long concrete made towers. And what usually happens is that depending on the design, it can be natural draft cooling tower or mechanical. Mechanical draft cooling tower usually has a fan on top. Now this fan, its purpose is to draw air from the atmosphere through the system upwards and then out of the tower from the top. So what usually happens is that there is countercurrent flow of the hot water and the air, ambient air. So water usually cools by evaporation. So usually when you see a cooling tower up, you can see something which is like a smoke. That one is air plus water vapor. So air draws heat from this hot water and then out of the tower. So as a result, because of this heat transfer which takes place in the cooling fins, water usually comes out and drops to the water basin down the cooling tower. And then it can go to the chillers for further cooling if it is required before it can be recycled. So the flow sometimes can be cross flow when air is, cross. When air is flowing across the direction of water. Then for natural draft cooling tower, there is no need for the fan. What usually happens that the differences in pressure, in the temperatures of the inside air, inside the tower, and then the air outside the tower creates that differential pressure, which causes the hot air to move upwards as the cold air gets into the system from the down inlets, the bottom inlet of the tower. So usually natural cooling towers, there is no need for mechanical force to draw in air.
Okay.
Yes.
So coming back to your company, do you provide process simulation consultancy?
Yes, we do.
And what softwares you have purchased?
At this level, we have AutoCAD software. This is a very good software. And then we also have Aspen HYSYS and Aspen Plus.
And what is your planning? Are you going to purchase more softwares as you progress in the market and you are getting various assignments or contracts? Then definitely you will really needs softwares to perform the job.
Depending on the need, I could purchase more, but as for now, these three can be okay for us because AutoCAD is a versatile software. It can be used by chemical engineers, can be used by civil engineers, architects, can be used by mechanical engineers. So it is a versatile software. And besides that, we have Aspen HYSYS and Aspen Plus. I think purchasing additional softwares at this level, it's not in plan.
Yes, if there is a need, you can also contract with other companies that provide services with the relevant softwares you need.
Yes.
And what is your future plan?
My future plan right now is to make sure Apple Vision Limited develops as an international consulting and engineering company that solves the most current problems affecting the world. And I hope to build a team which is geared and modeled to deliver excellence in their respective professions.
Are you planning to open offices in other countries as well?
Of course, that's part of the international strategy, business development strategy. It is part.
Great.
Would you want to partner with me?
Yes, of course. If you provide an opportunity, then I will definitely do work for you.
Please, we can discuss about that.
Thank you very much. And
you're welcome.
What is your message for the audience?
My message to the audience is this. I want the audience to understand the world as a system. I want the audience to know how the world has evolved from the traditional society to the current society that we have and the one we call the modern society. And of course, where the world is moving. There are three things that I want the audience to note. How has the world evolved from the traditional society to the modern society? Of course, you realize that science engineering, and technology have been at the forefront in transitioning this world from the traditional society to the modern society we have today. Despite all the good things that have come along with that transition, we should be in a position to recognize that the problems that we are facing today, reference, you can look at what United Nations, the 17 Sustainable Development Goals, clearly tell you the problems that the world is facing today. I want each and everyone who is listening to me to note that these problems are a result of the solutions that we tried to implement previously. The benefits we are enjoying today were as a result of the solutions that we implemented previously. And therefore, the problems that we are facing today are still as a result of those very solutions. That's why right now, you're looking at internationally, there are many international treaties that have been signed to ensure that the world should go to sustainability. If we are to make human life sustainable, everyone should think in a sustainable manner. Whether a chemical engineer, a civil engineer, a pharmacist, a doctor, use the profession you have, the knowledge and the skills and the experience you have as a tool to help the world transition from the modern society we have to a sustainable modern world. That's what I have for the audience.
Great message, Benard. Okay, so we wish you best of luck for your future, and we also wish that you get lots of contracts for your company in a short time. So, have you got vaccinated against the COVID?
Yes, I
What-
have.
What vaccine you used?
AstraZeneca.
AstraZeneca. Great.
Yeah.
Thank you very much, Benard.
Thank you for inviting me.
Yeah, welcome.